So we're continuing with radical functions and transformations in section 2.1. Just to remind ourselves what a regular untransformed radical function will look like, I've drawn y equals root x here. I just labeled a couple points so we can follow them along. We're going to now do a couple of different transformations to this function. The first one being y equals 2 times the square root of negative x plus 2. So there's a few things going on here. The 2 out front should be a vertical stretch by a factor of 2 about the x-axis. So the graph should get twice as tall as it was before. The negative inside should cause us to do a reflection, reflect about the y-axis. And then finally the x plus 2 in the innermost brackets there should be a horizontal translation of 2 units to the left. So we have to decide how to do all 3 of these transformations and come up with a final graph. If we go about these one at a time, if I just do a vertical stretch by a factor of 2 about the x-axis, I can see that the general shape won't change that much other than it still goes through 0, 0. It'll go up a little higher. So the point that I had labeled before used to be 4, 2 is now going to be 4, 4. We could label a bunch more points, but that's probably enough to get the point across. Now the second of the transformations is to reflect about the y-axis. So every x coordinate is going to change sign. Once again, 0, 0 stays at 0, 0. The coordinate 4, 4 is going to be negative 4, 4. And the whole graph will go the other way. Okay, so far we've taken our original radical function, we've vertically stretched it by a factor of 2 about the x-axis. We've reflected it about the y-axis, so our last job is to move it horizontally 2 units to the left. So taking these 2 coordinates we have labeled and just moving them 2 units to the left puts this one at negative 2, 0, and this other one is going to be at negative 6. Negative 6, comma 4, and it's opening up or curving over here to the left. If we're asked anything about the domain and range for the final function, the one that we've drawn at the end here, the domain is a little bit unusual in that x has to be less than or equal to negative 2. Because of that reflection, it's now going the other way. The range is the same, it's still just y has to be greater or equal to 0.